And I'm the creator and CTO of Ozcode. And with me here is Michael. Hi, Michael. Good evening.
Hi, Omer. Hi, everyone.
So today, Michael will be telling us all about logging in .NET. I'm really excited about this webinar because logging is sort of like the bread and butter of how we troubleshoot. And this webinar will be a very deep and detailed look into what does logging look like in the year 2020. We've come quite a long way. There's really exciting tools for working with logs, both on your personal laptop and in the cloud. There's fabulous new functionality that also is introduced where we can add logging to our software while it's already deployed to our production, staging, and QA environments. And there's just a lot to learn. So today, this session will be very interactive. If you haven't already logged into our Slack channel, the Ozcode Slack community debugging spot, please do. We'll be taking all the Q&A through the Slack channel rather than the Zoom. And one last thing, we'll be holding a raffle today. My colleague Michael is the celebrated author of the fabulous book, Practical Debugging for .NET Developers. And we will raffle off 5 copies, physical hardcover copies of this fabulous book among those of you who stay with us until the end of the webinar. So stick around for that. Without further ado, Michael, please take it away.
Thank you, Omer. All right, so let's get started. And today we're going to talk about next generation troubleshooting with logs. First, a little bit about me. My name is Michael Shpilt. I work as a dev lead in Ozcode. Recently published my book, Practical Debugging for .NET Developers. And you can find me at my blog, michaelscodingspot.com. So let's talk a bit about logs, starting from the very beginning. Why logs are so important? So logs became the industry standard, right? Everybody is using logs. And there are good reasons for that. Logs are very important. You all know this intuitively. Let's put it into words. So they provide a way to debug in production. When we have something deployed, it's like a black box, and logs allow to extract information, troubleshoot, find errors, and all that stuff. They show sequence of events. You can see what happened historically, which events led to other events, and troubleshoot using that. Logs are built so each log entry has a level, and this allows to easily filter to errors. And since it's the same with all the frameworks in all the languages, everybody's used to it. It's very convenient. Logs are reliable. If your process crashes, if the computer restarts, your logs will still be there. Besides troubleshooting and debugging, you can use logs to find the usage telemetry. For example, you can find out which features your users are using, or how much time in a day they're logged in. The logs can be aggregated from many machines, so you can visualize that usage and find out statistics from all that data. Also, logs can find those issues that can only be understood with a lot of data. So they are very important. Now, logs are problematic. For one thing, it's hard to find the relevant log sometimes. For example, a customer says, I had a problem at this and that hour with this and this feature. So now you go look at logs, and you have logs from a lot of customers. And there are many requests simultaneously from a lot of machines, and even from that specific customers, you probably have a lot of logs, and it feels like finding a needle in a haystack sometimes. Then when you do find sort of the logs from the same machine at the same time that are happen near that problem that you're trying to solve, you never have the right log. You might have some logs that sort of point you to the right direction, but it's like Murphy's law when you never have just the right log that you need. So you need to add more logs, but the more logs don't exactly give you the right information either sometimes. They just point you to a more specific location, which means you have to find even more, you have to add even more logs, and so on until finally in the 5th or 6th iteration, you have what you're looking for. And every time you add a log, it's not that simple. You have to add it to your source control. Then you have to deploy, and then you have to reproduce the bug and get the new logs. So in a microservice architecture, when you have multiple services, you need to get logs from those multiple services. And there are solutions for that. There's distributed tracing and correlation IDs and open tracing, all that stuff. But it takes effort. It takes knowledge that your team needs to know. It maybe takes some adding those correlation IDs to your code. It's not automatic and quick and effective. And today we're going to see how to overcome at least many of those problems. Maybe not all of the solutions to everything, but many of those problems. Now let's just talk a bit about structured logs. Structured logs became extremely popular in recent years. And well, traditionally a log entry was just a string, right? You had a timestamp, you had a level, and you had the message. And it was all just one string. But now a log is like rich data. It's a JSON or it's a list of properties, basically a list of properties and their values. Like in this example, we have the request info object where we have a URL property and the payload property, which means we can search according to those payloads. For example, we can find all logs where the payload was between 20 and 30, or a combination, like when payload was 30 and the URL was specific. We can also visualize that data, and those payload provide all sorts of telemetry and statistics and can help us find bugs. We'll see later on how to use modern tools in the cloud to utilize structured logs and how they're useful. Let's talk a little bit about logging frameworks in .NET. So first, once upon a time, Log4j was the most popular logging framework. Ported from Log4j. It had all the features we wanted. It had appenders, so we could log to different places, to different targets. You could modify the message template. You could add a level where you wanted, the timestamp where you wanted, and the context where you wanted. Then came nlog, and nlog was it had better API, it has a nicer setup, and it was a little bit faster. Everybody was a little sick from those XML configuration files Log4j had, so nlog sort of swooped the market and became the most popular. Oh, I see we have a poll here, so please choose your favorite logger, and we'll publish the results in just a little bit. So after nlog came Serilog, and Serilog was special because it introduced structured logging as a first-class citizen. And it had slightly better API and slightly better setup than nlog. And there was a hostile market takeover again, and Serilog became the most popular logger for a while. And now we have Microsoft Extensions logging, which basically a good logger that comes by default built in ASP.NET Core, and it has all the basic features. I'd say it's a bit less feature-rich than Serilog or nlog, but it's good enough for almost all cases, and many organizations choose to stay with it. But what I like about Microsoft Extensions logging is that it can easily integrate with Serilog and nlog. So you can use the iLogger of Microsoft Extensions logging, and it will pipe the logs to either Serilog or nlog. And from there, you can do all the stuff that Serilog does, like log to different targets and to database with all its rules and all that stuff. Here's a little, here's the Nougat downloads in the last 6 weeks, just to show you the popularity of those logs. You can see that Microsoft Extensions login is by far the most popular, but that's because every time you create an ASP.NET Core project from a template, it includes that. Also, Serilog is much more popular than nlog or Log4j. All right, so where do we log to? Now, traditionally, we've always been logging to a file, and that's a good option, and it still is, and you can combine it with other login targets. But now we mostly log to databases, which has a lot of advantages. You can gather data logs from multiple users, and you always oh, here are the results. Interesting. Log4net is first place. All right. Anyway, so database, we can log to any kind of database. We can log to relational database, NoSQL database. Time series database are especially suited for logs. And we now have SaaS solutions that are especially that are especially suited for logs. Some examples are Splunk and the Elk Stack. And those are highly recommended because they give you a bunch of tools around those logs out of the box with minimum effort. And we're going to talk a lot about Elk Stack a little bit further on. Just some more login targets is we can still use standard output and debug output, and not very common, but you can achieve a shared login target for both managed code and native code easily with the debug view by sysinternals. So that's useful for that. Windows Event Viewer is good for like critical events and stuff like that, but not for regular logging, I would say. And event tracing for Windows, if you have performance critical code, it's just extremely fast, and you can use event tracing for Windows to find those critical, to use in those critical sections. All right, cool. So I'll show you a few tools. So for years, I've been doing this. Like I have a log here from the Ozcode Visual Studio extension, and I've been doing this edit with Notepad++ for a very long time. And then I have a bunch of data, and I would scroll, and sometimes I would search for like error or exception or Ozcode or something like that. And that's okay. I mean, once you get used to the logs and you know what to look for, it's sort of okay. But then I discovered LogView Plus, and I'm going to show you this. Now, this is not the only tool, but it's a very good tool, and it shows you what these tools can do. So let's open the same log in LogView Plus. And right out of the box, we can see first that there are columns. LogView Plus automatically recognizes the pattern of your logs, and you can see it created a column for date, for time, for level, and for message. Of course, I can show and hide these columns. Next thing I like about it is that when we have long log entries, it's still shown here as one line, and then there's this master detail view where you can see the actual log message here below. If you look at the gutter, you can see there are red and orange lines. The red ones represent errors, the orange ones represent warnings. So in a glimpse, you can see the state of the logs, where there were errors in the timeline and stuff like that. A couple of more features where there's the text filter. So for example, I can filter on Ozcode. There's also the log level filter, so I can see only warn, error, and fatal logs, for example. There are some advanced features that I like. For example, I can right-click a column and group by this column, and then I can see how many entries of each log there were. Also, another nice thing is where was this? I can use this graph here, and I can see sort of the distribution. For example, I can see distribution according to level or according to message. So all those tools are pretty cool, and I recommend, if you're still using Notepad, choose this program or another similar program, and you'll never be able to go back. Now, the other thing I want to show you is Kibana. Now, let's talk a little bit about the Elk stack before moving forward. Now, the Elk stack is a group of 3 open source tools. E stands for Elasticsearch, L stands for Logstash, and K for Kibana. And the way it works is that whenever your logs go to Logstash, which sends them to Elasticsearch, which is the actual database. Database does the indexing and the high high search when you need it. And Kibana is the application, the UI application that does all the analysis and visualization. It queries Elasticsearch and shows you all the logs. So let's see that in action. And I have Kibana here with an application with a small application that I have. Let's say I want to see logs from the last 10 hours. And so what we see here, first of all, we're in this discover view, which is where you see the actual log entries. Here in this chart, you see the log distribution. For example, here I had 205 logs. Here I had 207 and so on. These are the actual log messages, but each log message can be expanded this way. Now, when we're dealing with the elk stack, each log is considered as a combination of properties. A level is a property, a message is a property, a logger is a property. And I'll just show you something maybe more interesting. So here, every property is the same. Even though I have this column message, I can remove it, and I can remove level as well. And then I can see sort of the source, just a bunch of messages. And then I can go to each column and I can add that message. For example, the request path, I can add it as a column. I can add the level as a column. And let's say I also want to add this span ID as a column. Now I can see it in this way, and I can sort according to level, and I can sort according to request path. Let's do it like this. And this is sort of the magic of structure logging. For example, I can create, let's just, I had some filters here. Let's just create a filter where, for example, I have this where level, well, that's maybe not a very good example. All right, level is error, right? And we can see only the errors, but that's a property like any other. I can also create a filter on request path or on span ID or on whatever. So another thing about Kibana is that they have these patterns here, and I can, if I just move message back, for example, we have a lot of messages which are the same, and not all of them are interesting. So I can go to patterns, and I can either include or exclude messages. For example, let's say I want to see only messages that are request starting. I just click here, and only messages of this pattern are shown. So we'll go back to Kibana and to the elk stack, but let's continue with the presentation. Now, I'm going to show you a little demo. We're all about troubleshooting with logs. So let's see a small bug that we want to troubleshoot. By the way, you can ask questions in our Slack channel, and then we'll answer them during the session, also in the Q&A in the end. Anyway, so I have a small application here. This is the eShop on web. It's an open source sort of very simple e-commerce store. It's an ASP.NET Core 3.1 app, and it has very simple functionality. It has a bunch of products. You can add each of them to basket and then purchase them. So let's say I have this .NET Bot black sweatshirt that I really like. I'll add it to the basket. Check out. Okay, so now I need to log in. All right, so check out, and now I want to pay. All right, so something went wrong. We see there was an HTTP error 500. This means that there was a request to the server. The server had some exception in it, and then and because of the exception, a 500 error was returned. So what do we do in these cases? How do we proceed? So one thing we can do is we can use the browser developer tools to find out the endpoint and just go to the source code and try to guess the bug. But that really leaves us with very little information. So another option is to first go into some kind of error monitoring tool. And there are many good tools. There's Raygun, which you might know. There's Elma, there's Application Insights. Ozcode shows you error details and much more, but we'll see that in a second. And then when you see the exception details, you have more information. Then you can go at the source code and sort of figure out the issue. Another thing you can do is to look at log files. At the log entry, sorry. So let's do that. Let's go to Kibana here. Now I want to see logs from the last 5 minutes. And I'm going to update this. I'm going to remove this filter. And I'm going to add a filter when I want to see only error entries, because this probably produced an error entry. And here we see something. We see a message saying an unhandled exception thrown by the application. Let's expand that. And here we see all sorts of interesting properties. We see the exception details, including the exception message, which was order failed. We see the stack trace of the exception, which shows that the method that threw the exception was validate order. Going a little below, we can see that the request path was basket checkout. These are open tracing. If in case you have multiple services and they're all using open tracing, then you can filter according to those and find all the requests. And sorry, so anyway, so that gives us much more information, but it doesn't give us all the information we have. Let's see what Ozcode can do. So at the start of this, I installed Ozcode for the application, and I didn't do anything. The Ozcode agent, I mean. So let's click here on Start Debugging. And here, this is the Ozcode's error feature. And it shows all the errors that happened in the application. And we can see that 3 minutes ago, there was an order failed exception. The exception type was invalid order exception. Its type was a failed request. And I can click debug here. And what we can see here, first of all, we can see the code in production. Now, this is the actual code from production. It's decompiled code. Unlike other solutions where you can, you don't have to match symbols to source code or deal with optimized code. It just always works. The other thing you can see here is the local variables. Now, if I scroll up a little bit, I can see sort of the method before in the call stack, which called validate order, and I can see the execution line and the local variables for this as well. So we can see local variables for all the call stack. Going back, we can see there was some kind of if statement, if errors.count more than 0, then there was an invalid order exception. And I can expand errors here and see the problem, but instead I'm going to show you another feature of Ozcode, and this is the logs tab here. And if I click on it, Ozcode shows me automatically all the logs that led to the exception. And what we see here is logs in the same HTTP request. Ozcode filters them automatically because they are usually the most interesting. So here you can see there was an entry get basket items returned one item. Then there was an entry validating order. And then it says item out of stock. And we can see some details on the item as well. Uh, so, so Ozcode's logs, what I like about them is that with basically zero effort, I can see just the relevant logs. I don't have to go to Kibana. I don't have to filter according to correlation IDs and take care to have span ID and trace ID and all that stuff. I don't have to do that. I see the error automatically as they appear. I'll click on the logs, and there we have it. I can click here on the toggle button, and now Ozcode will show me 1,000 of the latest logs that led to the exception from all HTTP requests or from something that doesn't have a request. And this is also useful in many cases where you have some kind of state machine, some kind of flow, something led to another, and then we have an error. All right. So to summarize this feature, Ozcode's latest logs, you get to see the 1,000 logs that led to the error. You can filter just the logs in the REST request. It doesn't have to be a REST. It can be WCF or gRPC request. And you can see structure logs. Now, let's consider for a second what we do when there's an error, an exception in a request. We talked about reproducing locally, but the thing is that you have very little information. You don't have exactly the same state that you had with the bug in production, so it's all just basically guesswork. Also, the code, the source code that you have in development might be different than the one in production. You might have a newer code. So in order to be accurate, you have to go back to the code, to the same code version that's in production. And it's all just a lot of effort. So the second thing you can do is to use error monitoring tools. And they give you the call stack and the exception details and maybe some contextual data. And that's great. That gives you much more information, but still you don't have local variables. You don't have you have basically just the exception details, which is still little information. If you then try to look at the source code in Visual Studio, you're still basically just using guesswork. Then we can look at logs, like we did with Kibana, but logs give you just partial information as well, because like we said before, logs are problematic. You never have the right log. You always need to add more logs, redeploy, reproduce the problem again, look at the new logs, and maybe add even more logs. And Ozcode is special in the way that you can see the latest logs automatically without having to filter. You can see the exception details, but even more importantly, you can see the actual source code with the line that threw the exception and the local variables. All right, moving forward, I'll show you another bug, because today we're all about troubleshooting bugs. Going to our application. Let's hope it didn't log me out again. All right, so I'll just return the basket to 0. Basket is empty. And this time, let's say I want to buy this .NET Foundation sweatshirt. I'll add it to basket and continue shopping. And now there's this Roslyn red sheet that I like. I want to add it to basket as well. So we can see the Roslyn red sheet. It costs $8. And .NET Foundation sweatshirt costs $12, and together they cost 16. This doesn't make sense, right? It should be where the $4 disappear. So we have some kind of logical bug, in some kind of calculation bug. What can we do now? We have similar options like before. We can look at the source code and try to guess what happened. you look at logs. We can maybe attach a debugger, but attaching a debugger is pretty difficult in production because first you have to match symbols and source code. So you have to go back in your source code in the development machine to the exact source code that's in production, and you have to do this matching. It's not fun. The second thing is optimized code. In production, you build and release, you deploy, the code is optimized. And optimized code means breakpoints don't work and some local variables aren't shown. So it's all really rather difficult. Okay, so let's try looking at logs. Let's go to Kibana again. I'm going to remove this column. I'm going to remove this column. And I'm going to refresh for logs in the last 5 minutes. We have a filter here, which I removed. All right, so we have executed handler methods and the executed page, entity framework, executed an implicit handler method, get types called, entity framework. Seems like a bunch of rather useless logs. Oh, here is maybe get basket items returned 1 item. Well, that's not very useful. Executed page index. Up. All right, it doesn't seem like there's a lot of useful logs here. So let's look at the application again. Here I have this total, and let's go to Visual Studio and see and try to find it in code. So I'll just gonna look for total here and try to find the same page that's in Visual Studio. I'm going to check out here. I have this total, and I can see here model.basket.total. This is probably the method that calculates total. So let's go here, and I can see we go over each item, we calculate the price, there's something with the discount, and then we sum the result. So in normal circumstances, I would insert here some kind of log entry, redeploy, reproduce the bug, and try to figure out what happened. But I'm really lazy and I don't want to do that. I want to solve the bug as quickly as possible. So instead, I can use Ozcode's new Tracepoint features. And a tracepoint in Ozcode is kind of similar to a breakpoint, except that unlike a breakpoint, it doesn't actually stop the execution of the code. Let me show you what I mean. I'll just create a tracepoint session. Let's call it wrong total. And now I have to go to the code, and which class was it? It was basket view model. So I'll just look for it here. All right, here is basket view model. And I can see here the same code that's in production. And here is the total method. I'll just place something here, hello world, and let's see what happens. Start collecting. And now I'll refresh the page. The method total should have been called again. And here we see a hello world message. All right, let's click on it. Okay, so what do we see here? First, we see the method. We see the execution line where we place the trace points. But most importantly, here we can see the local variables at the time the trace point was hit. A trace point is basically a snapshot of at the current moment where you can see a similar information to what you would if you stopped on a breakpoint in Visual Studio. Now, because it's the first line in the method, all the local variables are default values. And I have this here, which shows me all the class members. And here I have items. So what I could have done is I could have expanded these items here and figure out the bug. But again, I'm too lazy for that. So I'll just place another breakpoint, another trace point here, and I'll say item. I'd like to know its ID, and then maybe I'd like to know the price as well. And the discount factor seems very suspicious here. So maybe I'll log that as well. And I also care about the result at this point. All right, so that looks good. Let's refresh again and see what happens. So, okay, so I got something. I got here an item with the ID 3, the price 12 discount, and the result 12. All right. And here I have another item with the price 8, discount 0.5, 50%, and the result 4, which gives us 16. So basically there was a discount of 50% on this product, but the discount isn't shown anywhere. So either we should show the discount, or maybe there shouldn't be a discount in the first place. Whatever the reason, 90% of the work is done, because now I know the source of the root cause of the bug. All right, so Ozcode's Tracepoints. We basically achieve dynamic logging without redeploying. We can add logs without all that trouble. We capture a snapshot with local variables. So it's actually more than just a log. It's an actual snapshot where you can see all the good stuff you can see in Visual Studio, and pipe tracepoints as regular logs to any login framework. So I didn't show you this part, but actually if I go to Kibana and I'm going to refresh again, and you can see here that I have the same trace point that I added, the same log that I added via the trace points. So basically Ozcode can integrate, if you want, with your existing login framework. And this way you can get to use all the tools you already know, but just add the logs dynamically. And this integrates with anything. It integrates with all the login frameworks, Serilog, Nlog, Log4net, whatever you want. It can integrate with all the SaaS products like Splunk, Elk, and all that stuff. And actually, this feature is now in early access program. So whoever wants to try it, whoever has maybe some pesky bugs in your product right now, and you could use this kind of feature, talk to us. You can talk to us right now in the Slack channel or in Ozcode.com in the website, and we'll get you right in the program. Okay, so here's a small table of how do we proceed when we have a logical error happens, and the logs don't show you enough information. So reproduce locally, we talked about that. That's basically guesswork. Attach a debugger, a lot of effort. Add in more logs, also a lot of effort. I don't want to redeploy stuff and reproduce bugs. And Ozcode's Tracepoints pretty much solve a lot of those problems. You get dynamic logging, you get snapshots with local variables. Yeah, and that's basically it. Thank you very much. We're going to Q&A right now. So
Awesome. Thanks, Michael. That was an awesome presentation. I really like the thing you just showed at the end there, where I can whatever kind of DevOps SRE flow I have going for troubleshooting, analyzing logs that are coming in from different services. I can add these live trace points from production systems. I can add them on the fly, and they go right to where my logs are currently going, right? The same sort of incident response flow that we have of how we handle issues as they come in and we try to troubleshoot them can stay the same, but this just gives us another layer of information. So that's really great. So let's go to Q&A. We've got some interesting questions from the audience here. So the first questions was, are there any performance implications to using the Ozcode Production Debugger?
yeah, so if we're talking about trace points, when you if you don't hit that code where you place the trace points, there's basically no performance implication. Where when you do hit that code, then there is very small, extremely optimized performance implication, because we need to gather all the local variables and send them to our server. So that that does have some overhead, but again, it's relatively very small. For
Essentially, it's I would say it's comparable to adding a log statement there, give or take, where you're just capturing all the locals into the log statement.
Yeah.
Awesome. So let's take another question here. There's a question from the audience. What was that first tool that you showed for analyzing logs? Is it from Ozcode? So no, so that tool is called LogView Plus, and it's not an Ozcode tool. It's made by an independent developer. Just thought that we'd show you that because we really enjoyed it, and we use it internally on the Ozcode team and really liked it. Boris asks, will there be a recording of this webinar available? Absolutely, it will be available in just a few days. Next question. Rami asks, how do you set up the integration for the different logging targets with Tracepoints?
Yeah, so we basically have two ways. The first way is you can consume our Nougat package, and whenever there's a Tracepoint hit, you can register to our event and do whatever you want with it. You get all the information, the message, the properties, and then you can pipe it to Serilog or Nlog or Log4net, and it will do the rest. That's the usual use case. A second feature is that we, in the server side, that's actually still in development, but will be out soon. That's in the server side. We will integrate with some of the more popular tools like the Elk stack, and then you don't have to do anything in code. When it will reach our server, then we will send it to those tools.
And what I like about that, by the way, is that there's really no limit to what you can integrate with. Like, let's say you want to set it up so that when we hit this specific line of code, if the value is, I don't know, John Smith, I want to get a Slack message, a PagerDuty notification, Microsoft Teams notification, whatever it is you want to do, set that up, right? The integration is endless. Awesome. So next question here. So Fabian asks, when creating a Docker container, would you say that console logging from within the container is enough, or should the container itself connect to some Elasticsearch, application insights, etc., in order to create structure log? I think console logging is what's expected or maybe customary from a container, but that means just string logging again, no structured logs. So what would you say to that, Michael? I know in the Docker container world, a lot of people just pipe it all out to the console output, and then they through the tools that Azure or AWS provide, or the Google Cloud managed Kubernetes services provide, you can connect to that console stream that the Docker container sends out. But would you say that it would be a good idea to use a third-party tool on top of that, or would you say that that's enough?
Yeah, that you will definitely benefit from third-party tools, because you can integrate structured logging and distributed tracing. You'll be able to see logs from many machines in one place. So yeah, I would say it has a lot of advantages.
Absolutely, I would agree. I'd say that in the Kubernetes world, this notion of distributed tracing, that, by the way, you get out of the box, and we showed a quick demo of this in our last webinar. We'll go even deeper on this on our next webinar. But basically, when you add all the Ozcode agent to your Docker containers or to your Windows services, whatever it is, Ozcode adds open tracing out of the box, meaning we add that correlation as you send requests from one service to the next. And that's extremely useful because if you have 10,000 people using your site at the same time and you're trying to track down just the log entries or the trace points that are relevant to the particular customer that had a problem, that distributed tracing is extremely useful. Awesome. So, and also the benefit of structured log, again, something that is becoming very much a must-have nowadays, just being able to filter by values. And I would say one more thing to that point is that once you have structured logs, you can start using your logs as metrics, as Michael talked about. Tools like Kibana and also Grafana that somebody in the audience also asked about allow us to create visualizations from the logs, take some sort of value, create a pie chart, create any sort of graph that you'd like. And that's extremely useful because we can very easily visualize information that's coming from our production environments. Awesome. So Boris asks, how do you set up the integration with application insights for this?
What you can do is if you have Serilog, for example, or even Microsoft extensions logging that already logs to application insights, then you can just register to our event. And whenever there's a hit, you write a single line of code that will log to your existing logger, and that will pipe the message to application insights.
And of course, we also support the standard sort of native vanilla application insights iTelemetry client. So if you're using that directly rather than piping through Serilog, as most people do, you're supported just as well. Awesome. So let's carry on with the questions here. How do I set this up when I have a client WPF applications on the same network and having access to central store and SQL databases?
Sorry, can you repeat that?
So Pascal asks, how do I set this up when I have WPF client applications that are all, if I understand the question correctly, it's a situation where we're isolated. We're on a separate network. All of the, we're probably cut off from the public internet in this scenario. Okay. All of the database and the WPF application talks to is all on that same network and it can't go outside. What do we do in
yeah, so you can install Ozcode's on-premise solution where you install our server on your private network, and then we don't have access to that server, only you have access, and everything will report to that server, and you don't need the access to the public internet.
Awesome. And by the way, it's interesting to mention that you can do the same thing in terms of having it on premise for the Elk stack as well. Right? The Elk stack is an open source solution. You can just install the Elk stack on your local network, even if it's completely isolated from the public internet. You can do that using Docker or many other solutions. You also have the option of using a hosted Elk SaaS solution, actually pay money for from companies like CoreLogic, Logs.io, and of course Elastic themselves. Probably preferable if you have a lot of logs and you don't want to deal with maintaining Elk yourself, which can get scary. Awesome. So let's continue on with the questions here. I think we're almost out of questions. We've answered the question about performance implications. Will your tool work with desktop applications, WPF or WinForms? So yes, the Ozcode Production Debugger works just as well with WPF and WinForms applications. You just have to make sure that you install the agent on the machine. So you can essentially package the Ozcode agent installer into your own installer so that it will silently run the agent behind the scenes. Alrighty, next question here. Is there a preference of frameworks if I want to use the Elk stack? do I have to use Surilog or one of the other, or does it not matter?
No, it doesn't matter. Like you have appenders for all the popular frameworks to the Elk stack, and if you're using managed solutions like I did for Logs.io, then Logs.io themselves have a small Nougat package. I'm not sure if it's for all the. I would guess it's for all the login frameworks. Really, I don't think they.
I would say so. Awesome. So we got a couple more questions here from the audience. Stefan asks, does Ozcode have any form of filtering sensitive data from logs so that you can avoid GDPR issues? So I'll take that one. So Ozcode does have PII redaction. We treat compliance to the most stringent regulatory constraints as one of our top priority features. So you have extremely convenient ways of configuring redaction by using regular expressions and identifiers. We talked about it a little bit in the previous webinar. It applies to our exception view just as much as for the trace points. So all the information that you'll see both in the Ozcode Production Debugger and the information that you can pipe out to external log source as we showed will be redacted. There is also a way of controlling your retention, which is also very important for some companies. If you want to limit your GDPR liability, a good way of doing that is to just have a company policy of, in general, we're not going to save data that is more than 1 month old in our monitoring systems. So you can set that up to whatever retention span you'd like for the Ozcode Production Debugger, and the things that are very hard to implement about GDPR, like the right of erasure, that will sort of ease your mind there, because you have full control of how long do we retain the collected data. Next question is kind of interesting. Stefan also asks, will Ozcode have in the future some sort of decision-making algorithms so it can react to specific defined errors? What would you say to that, Michael?
Right now, Ozcode reacts to 4 types of errors automatically. Those are crashes, failed requests, logged errors, if you say log.error, and first chance error. So basically everything that's an exception. We don't plan to I would say this: if you know there's some kind of error, let's say you know that if some code enters, there's an error, or when a certain variable when it equals to something, then you'd like to report an error, then you can use Tracepoints with a condition, which is something that will be coming soon. So basically, you can place a trace point, but you can use it with a condition, and that condition can be according to the variables, and that will probably satisfy that need.
Awesome. All right, Michael, I think we're just about out of questions. So thank you everybody for joining us today. Again, if you'd like to get started with Ozcode, just go to app.ozcode.com, sign up for the website. As we mentioned, the Tracepoints feature is entering the early access program. Is very easy. Just reach out to us and we can put you on the early access program. Very happy to get your feedback on these great new features. And as I mentioned before, 5 of you who have stuck with us to the end will be receiving a very happy email that you have won the raffle for the book Practical Debugging in .NET, which we will ship out to you, the lucky winners, over next week. Alrighty, thanks again, Michael. Thanks everyone for joining us, and we'll see you on the next webinar.
Bye, everyone.
See you later.